All right, guys. So in this section 6.2, what do we have? Problem number 1, graph each function. So do not use the calculator. I am basically, if you don't want to use the calculator, what you need to do is having a value of y, choose the value of x and find the value of y, which is f of x. So when x equals 0, you will add 3 to the 0. When x equals 1, you will add 3 to the 1. When x equals 2, you will have 3 to the 2. When x equals 3, you will have 3 cubed. But because you know it's not a linear function, you may want to use to the negative 1, to the negative 2, to the negative 3, which will bring you to 3 to the negative 1, 3 to the negative 2, and 3 to the negative 3. Reminding you that 3 to the negative 1 is 1/3. 3 to the negative 2, it's 1 over 3 square, and 3 to the negative 3, it is 1 over 3 cubed. But what I'm going to do is I'm going to be a little bit more quicker than that. I am going to choose my function, go in the mathematics, and I'm going to try to graph that function f of x. One cannot complete the graph evaluation. Oh, dang it. It doesn't do it. Can it do it this way? Yes, it can do it this way. Perfect. Okay, so you can see that you have, don't pay attention to the purple line. I need to figure out why we have this purple line, but the red graph is the graph corresponding to 3 to the x. All right, guys, so now let's continue to problem number 3. On the problem number 3, we have f of x equal 1/3 over x. So same idea. On this problem number 3, it is exactly the same idea. 3 is f of x equal 1/3 to the x. It's not a linear function, so to graph this function, and I will let you do that on your own, you are going to choose the value of x, and then you are going to find the value of y, f of x. When x equals 0, you will have 1/3 to the 0. When x equals 1, you will have 1/3 to the 1, etc., etc. Don't forget to take negative value. So I will move on to problem number 7. And the problem number 7, it's about solving the equation 1/2 of 2 to the x equal 4. Well, when you have an equation like this, what I suggest to do first is to look at if you have something looking like a to the b equal a to the c. And if you have the same base, in that case, for instance, the base is a, therefore you can equal the exponent by having b equal c. So what do we have right there? We have 1/2. I would suggest that when you are dealing with a fraction, transform the fraction remembering the rule of exponent, knowing that a to the negative n equal 1/a to the n. Therefore, 1/2 is equal to 2 to the negative 1. So now I can write 2 to the negative 1 to the x equal what? 4 is a 2 square. So I got 2 square. So we are almost there because we're having the 2, but we are looking for, so we are looking for a base 2, but I have to the negative 1. I'm going to use the rule of exponent that's saying that a to the n to the m end up to have the multiplication of the exponent. Therefore, I end up to have 2 to the negative x equal 2 square. And now I have the same base, exactly the same base, which is base 2. So I can equal the exponent. And so I can write negative x equal 2. So x equal negative 2. All right. Let's try to do problem number 8. If I do the problem number 8, we got 2/3 to the x equal 9 to the 4th, 9 divided by 4. So I want to simplify 9 to the 4th. I can see 9 is a 3 square, 4 is a 2 square. So I can literally have 9 to the 4 equal 3/2 square. So if I substitute 9 to the 4 by 3 over 2 square, I end up to have 2/3 x equal 3 over 2 square. I'm pretty close because 3 divided by 2, 2 divided by 3, I got the same number. Obviously, I got the inverse. And again, I need to remember that a to the negative n equal 1 over a to the n. So I can literally write two things. I could write 2/3 equal 3 over 2 to the negative 1. Or I could write 3 over 2 equal 2/3 to the negative 1. I can decide to change my 2/3 into 3 over 2 to the negative 1 or change 3 over 2 into 2/3. I'm going to change the 2/3 because we are used to write from the left to the right, right? But it doesn't matter at the end. And so I end up to have 3 over 2 to the negative 1 to the x equal 3 over 2 square. Using the same rule of exponent a to the n to the m equal the multiplication of your exponent, I end up to have 3 over 2 to the negative x equal 3 over 2 square. And in that case, again, I'm going to be able now to equal the exponent, negative x equal 2, and so x equal negative 2. All right, next problem. All right, guys, so in this problem number 13, you just need to plot 4.1 to the negative square root of 3, and you will find a value given by your calculator. Problem number 19, it's about using your calculator to graph the function y equal 1 over 2 to the x. I am going to try to use the function that I have with this. Let's see if I'm able to do this. It doesn't seem that it is calculating. I don't see anything. So let's see if I can do that. Here we go. So I was able to, I need to figure out why it's graphing me two lines, but that's okay. Don't worry. What you have right here is the expression 1/2 of to the x. If I decide to graph the other one, so I'm going to try to see if I can graph number 23 e to the x, e being a number, so exponential to the x. There we go. Obviously it doesn't work, but if I decide to have this, so that will be in red the expression of f of x equal e to the x. Okay? All right, so that said, or maybe I can insert that into the page. There we go. That's what I should have done. I can insert that to the page, and right here in red we have the function. Okay, right now we'll try to remember that for next time. Okay, so now problem number 32. What do we have for this problem number 32? So in this problem number 32, we refer to the graph. So we have a graph. So briefly, let's see if I can. No, I can't do that. All right, so it doesn't show me. I wanted to do something different. So we have a graph. This graph is basically showing something like this. We right here a point 0, 1. Then we have a point 1a right there. Then we have a point right here, negative 1, a to the negative 1 for the value of y. And right there we have 0 being the axis y and this being the axis x. And the first question is a greater than 1 or is a between 0 and 1? And a is in between 0 and 1. Okay, so the question a is in between 0 and 1. For the question B, give the domain. So when I look at my graph, I can clearly define the domain being equal to negative. The domain will be equal to corresponding to between negative infinity and plus infinity. give the domain and the range. So when I look at the range, I can clearly see that it is 0 plus infinity. And the equation of the asymptote is an horizontal asymptote. We're having an horizontal asymptote at y equals 0. Why is this horizontal asymptote? That's the asymptote. And it's basically the line that the graph will tend to go to, but will never touch it because the value of y cannot be equal to 0, basically. Problem number, for the question number D, what do we have? So for D, so that was for, so for C, I'm sorry, for C we need to sketch the graph g of x equal negative a of x. So we need to sketch negative a to the x. So if that in blue corresponds to a to the x, what would be negative a to the x? Well, remember that basically what we have, and if I call, actually I'm going to represent that in orange, and if I call this g of x, and if I look at f of x being equal to a to the x, I can definitely say that g of x equal negative f of x. And I'm supposed to remember that means we are having a symmetry regarding the x-axis. And if we're having a symmetry regarding the x-axis, we end up to have our graph that is going to be like this. And that will be negative a to the x. All right. For D, give the domain and the range for this function g. So for this function g, the domain for the function g will be negative infinity plus infinity again, but the range this time will be negative infinity to 0. As the asymptote, horizontal asymptote, will be still y equals 0. Now we need to graph the sketch a to the negative x. So now if I'm looking at the question E, which is graphing the sketch of the graph a to the negative x, I would like to remind you that corresponds to 1 over a to the x. So what are we saying basically? We are just saying that if I'm looking at f of x being equal to a to the x, I can clearly say, and let me use the green this time, that the new function, when we call h of x, is the inverse of my function f of x. So therefore, what I'm going to do is I am going to have on my graph, and let me use this graph right here, I am going to have the function h of x that will be the inverse of the function g of x right here. That will be the inverse function of f of x right there. And if I want to be realistic, basically what I should do is I should go for this point right here, and we're having h of x. There we go. All right. So let's move on to the problem number, and obviously what will be the domain of this function in h of x? Well, the domain of this function f of x will still be negative infinity to plus infinity. The range would end up to be this time 0 plus infinity, and you have a parenthesis on the 0 because y equals 0 is an asymptote, and the asymptote, horizontal asymptote, is y equals 0. All right, guys, that will be all done. That will be all for the first part, and let's move on to the second part of this chapter 6.2.